Hello viewers, in this video I will discuss on the concept zeroth law of thermodynamics. So let us see the statement of this zeroth law of thermodynamics. See, two systems in thermal equilibrium with the third system separately are in thermal equilibrium with each other. Okay, so let us now explain it now. So let us take system A and a system B and also a system 3. So now I have taken 3 systems. Okay. So now if the system A, when the system A is in thermal equilibrium with C separately. Okay. So now A is in thermal equilibrium. When A reaches the thermal equilibrium with C separately, and then now B, when B reaches thermal equilibrium with C separately, if that is the condition, A is in equilibrium with C and B is in equilibrium with C separately, then automatically A and B will be in thermal equilibrium with each other. That is this zeroth law of thermodynamics. Okay, see that two systems A and B are with the third system, that is in thermal equilibrium with the third system. So A and B are separately in thermal equilibrium with C. So that is the statement. That will be are in thermal equilibrium with each other. So automatically A and B will be in thermal equilibrium with each other. How it could be done? See that here I have a system A and B separated by an insulating wall. So here I have an insulating wall separated by insulating wall, but A and B are in contact with C by a conducting wall. So by conducting wall, A and B is in contact with C separately. Okay. So now what happens? A will reach in thermal equilibrium with C separately and B will reach in thermal equilibrium with C separately. So now I will close C, the connection of A and B with C by putting an insulating wall between C and B and A, between C and A and B. Okay. So now I am connecting A and B with a conducting wall. So now what happens? A and B will be in thermal equilibrium with each other. Okay, so this is the way of creating thermal equilibrium with the three bodies. Okay, so the best example of zeroth law of thermodynamics is nothing but your mercury thermometer. Okay, so let us imagine this pen as your mercury thermometer. So this pen outer layer, let us take it as the outer layer of the thermometer, and this inside this pen, let us take this as your mercury indicator. So in your normal mercury thermometer, you will be having inside a mercury indicator. Okay, so let us take this as your pen as your the outer solid of the outer glass particle of the thermometer. Okay, so what happens? So when we go to the hospital, normally doctor will keep this thermometer inside our mouth, and which is used to check the temperature of the patient. Okay, so that we are following here. So in ABC, let us take A as the mouth of our patient. Okay, so normally when we keep this thermometer inside our mouth, we can see that the so let us take the C as the outer part of the thermometer. Okay, and this B as the mercury indicator inside this level, this mercury indicator. Okay, so when A is the mouth, so when thermometer is kept inside our mouth, what happens? A will try to reach thermal equilibrium with C. So the temperature of A will reach C now. So it will take some time. So doctor will wait for some time after keeping thermometer inside our mouth. What is the reason? Because it takes some time to reach the exact temperature of the mouth. Okay, so the exact temperature of the mouth will reach C, or the outer body of the thermometer. So after some time, we can see that this temperature maintained at C will reach B. So the C will try to maintain thermal equilibrium with B. Automatically, we can see that the temperature of C will reach B after some time. So that will be indicated by the mercury. So the mercury starts rising and it will come to the mark of which indicates the temperature. So that is a method to is followed to reach the temperature. So doctor sees that, oh, the temperature is approximately 102 or 106, like that the doctor says after some time. Okay, so this is the way of finding the temperature of the patient. See that A reaches equilibrium with C and C reaches equilibrium with B, automatically A is in equilibrium with B. Okay, so the exact temperature of the A is indicated in the mercury level. So this is the example demonstration of zeroth law of thermodynamics. Okay, so this is the explanation of the zeroth law with an example. Okay, thank you.